Alright gang, here we go. We're in chapter 7 now, and we're dealing with networking. We've talked about networking to a degree when it comes to the peer-to-peer and the domain networks. And we talked about that in the last few chapters. So the objectives, we're going to understand Windows 10 network components. We're going to describe and configure IP version 4 and IP version 6, and perform and monitor file sharing. We're going to connect Windows 10 to the internet, describe and configure wireless networking, configure Windows Firewall, and describe Homegroup Networks. Let's talk about networking as a whole. Now, the basic components of Windows 10 that support networking are Network and Sharing Center, Networks, and Connections. Network and Sharing Center is a central point in Windows 10 for managing the configuration of the network that you're connected to. Now, there's areas where you view your active network and change your network settings. And here's our interface for Network and Sharing Center. And we could see the type of connection that we have, the name of the connection, that it's a public or private. So network location awareness, it allows you to configure the security settings for each location type differently. Configuration settings for each location type are saved. And when it comes to a network name, when you first connect to a network, the network is given a name to identify it by Windows 10. Wireless networks are named after the broadcast idea of the wireless access point. Now, most of you are familiar with, at the college, we've got the PAW guest. That's the access point. So your system recognizes that broadcast ID. We've got location types. We've got private, public, and domain network. There's network discovery that provides you with an easy way to control how your computer views other computers on the network. It advertises its presence on the network. You've got the options to turn on or turn off network discovery. For each network device installed in your computer, that connection is created to manage that network device. We've got clients and services, such as there's applications that can use the network to communicate. The client allows you to connect to a particular service running on a remote computer. A service allows your computer to accept connections from and provide resources to a remote computer. So here's our connection itself. And this is the Ethernet 2 properties. And our connection, we could set client for Microsoft Windows. We can see that we've got the ability to associate IP version 4, or a little further down, IP version 6, QoS packet scheduler. There's a number of different connection uses we can have for this connection. Now, clients and services include, with Windows 10, we've got client for Microsoft Networks and file and printer sharing for Microsoft Networks. It's a QoS packet scheduler. And we've got that QoS packet scheduler, and you'll see it, noted it back in that previous interface. Now, both the client for Windows or Microsoft Networks and file and print sharing for Microsoft Networks, they use Server Message Block Protocol, SMB. So, different protocols. Now, what is a protocol? Protocol is the rules for communicating across a network. I guess the easiest thing, if you were in, say, elementary school or primary school, there was a protocol that you can't speak until you've held your hand up and you were acknowledged by the teacher, and then you could say whatever you had to say. But there was no, I'll just say whatever I want to say when I want to say it. That was the protocol for the classroom. Now, these protocols define, when it comes to IT or network communication, these protocols define how much data can be sent and the format of the data as it crosses the network. The protocols that are supported by Windows 10, the most commonly used one that we're going to deal with is IP version 4. It's TCP/IP version 4. We've also got version 6. We've got link layer topology discovery map or IO driver, link layer topology discovery responder, and Microsoft LLDP protocol driver. Now, network driver, that's responsible for enabling communication between Windows 10 and a network device on your computer. So let's say the network device is a network interface card or a wireless network card. It's the physical hardware that allows us to connect to a network. Now, I say physical hardware, it's either an add-on or it's integrated into the system itself. It could connect to a physical cable connecting to our system or allow us to connect via Wi-Fi to the network. In either case, we are talking to the network or communicating with the network. So that physical hardware, we need to have a driver or software that's written that allows our operating system to control and communicate with that other piece of network hardware that is part of our system. Windows 10 includes several interfaces and make it easier for developers to create client services, protocols, and network drivers. They provide a standard way for clients and services to communicate with protocols and a standard way for protocols to communicate with network drivers. TCP/IP is the most popular networking protocol today, and version 4 is the standard. Now, version 6 has been adopted for many years, but we haven't all migrated over to version 6. Only TCP/IP is included with Windows 10 for network communication. Windows 10 has the ability to use multiple protocols. Each computer must have a unique IP address to communicate on the network. Much like for you to talk on a phone network, you have to have a unique identifier or your phone number. A computer needs a unique identifier, which is the IP address. Now, IP addresses are most commonly displayed in dotted decimal notation. So you've got 4 sets of decimal numbers called octets. So here's a common one, 192.168.5.66. The value of the first octet determines the general class of an IP version 4 address. So we've got, for that first octet, 0 to 127 is a Class A IP address. 128 to 191 is a Class B IP address. 192 to 223 is a Class C. That's what we see most commonly in our classrooms. And 224 to 239, Class D. 240 to 255 is a Class E. Now, in special cases and considerations, if the first octet is 0, the remaining octets identify local machines on the same network. A first octet value of 127, that identifies a destination that is local to the computer sending the data. It's what we call a loopback adapter address. An IP address has not been assigned to the device, so this is generated on its own as a loopback adapter. Now, the first octet identifying a Class D address represents a multicast address. First octet identifying a Class E address is reserved for future use and special purposes. So the Class D and Class E we won't see. So that's 224 up to 255, not commonly used. 192 is probably the most common you'll see. Okay. So several ranges of IP addresses are reserved for internal network use. A proxy server or network address translation must be used, NAT. That provides internet access to computers using these addresses. Addresses for internal networks: 192.168.0.0 to 192.168.255.255. So we've got 200, from 0 to 255. That's our range. There's another one, 172.16.0.0. There's another range of up to 255. And 10.0.0.0 up to 255. Now these are separate, distinct, and they won't talk to each other. Now, IP address is composed of a network ID and a host ID on a subnet mask. We've got the network ID and the host ID, and the subnet mask, it defines which part of an IP address is the network ID and which part is of the IP address is the host ID. So a subnet mask's bits are set to 1 to identify what part of an assigned IP4 address belongs to the network ID. Bits set to 0 identify what part of the address belongs to the host ID. The class's interdomain routing CIDR notation is this. It goes from 1 to 16. Now, here's our subnet masks. So we would have an IP address. That IP address would have a subnet mask. So we've got default gateways. They're routers that control movement of packets through networks. Default gateway is a router on the local network that's used to deliver packets to a remote network. So it's like your go-between between your network and the outside world. Now, Windows 10 stores the default gateway setting internally as part of a larger table called the routing table. Now, DNS is domain name system. So we usually will have on a domain name server. Can't have a domain without a DNS. And it's essential to communicate on a TCP/IP network. It resolves host names to IP addresses. So it's kind of like somebody that keeps track of names and phone numbers, so that if you want to communicate with somebody, all you need is their name. You reach out to the DNS system with the host name, and it'll resolve it to an IP address for you. DNS is essential for internet connectivity because most people use domain names, not IP addresses. So it's kind of like your phone. We don't remember anybody's phone numbers anymore, just their names. Same thing when it comes to websites. I don't know Google.com's IP address, but I know Google.com's name. It's Google. Google.com. Okay. So we've got some legacy technology and Windows Internet Naming Service. That's legacy technology used to resolve NetBIOS names to IP addresses. Stores information about services such as domain controllers. Not something that we'll use at this point. There's methods for configuring IP version 4. It can be manually entered. It's not very efficient, but it's stable. Or we can use what we call DHCP, or Dynamic Host Configuration Protocol. It allows us to lease out or let people use IP addresses for a specific duration. The IP address is not manually configured, it's dynamic, and all you do is connect the host system to a network. The network adapter will then reach out, or our system will reach out to the domain controller, and find a domain controller. If it's founded, if the relationship's there, it will receive an IP address dynamically. It's kind of like we borrowed a phone number for the time being. Now that's ours. There's a finite number of them. And if you log on to a Wi-Fi adapter using your mobile device, you're using this DHCP. You don't have an IP address manually configured on your smartphone. It goes and gets the IP address and borrows it while it's communicating with that network. Now, there's APIPA, Automatic Private IP Addressing. It addresses on the 169 network. It's designed as a solution for very small networks with no internet connectivity requirements. Windows 10 allows you to configure a static set of IP configuration options if a DHCP server can't be contacted. We use this alternate IP configuration instead. So here's our interface. Automatic private IP address, and we just configure what's what when it comes to it. So here's IP troubleshooting utilities. How do you troubleshoot it? What's the host name? What's IP config? So these are commands that we would run and a command prompt to find specific pieces of data. So if I started a command prompt and I typed in IPconfig, it will give me the current IP version 4 and IP version 6 configuration. Some of it. Or I could type in IPconfig/all, and it will give me every piece of information associated with that device, that network device, how it's configured, and what the IP data is. Now, these others, we can talk about them later. They're powerful, powerful tools in a command prompt to be able to check these values and see how things are working and if they're working. So here's the IPconfig-/all that I told you about. We can release the IP address, lets go of any dynamic IP addresses, and we can renew it. It goes out and grabs a new IP address. We've got pings where we can ping a specific machine on the network, or I should say test to see how long does it take to connect to another device, and we'll send packages out and get packages back. And if I did ping 4, it'll force the use of IP version 4. Ping n specifies a number of requests to send. I think traditionally we'll run 5 requests. And the request goes out. How long did it take to get a response? It gives us an idea of how efficient is our network and is it actually working. We've got NetStack for network troubleshooting that displays connections and active ports waiting for a connection. Now, troubleshooting IP version 4, confirm the current settings, IP config, netsh. Most of this we just talked about while we had it up. Now we've got improvements in version 6, increased address space, hierarchical routing to reduce load on the internet, backbone routers. This is something that we don't see it used as much as it should be used today. IP version 6 addresses are 128 bits long. Once we run out of space in our IP version 4 system, we'll bump up to IP version 6. It's just a matter of time. Okay. All right, methods for configuring IP version 6. Now, the Win 10 automatically configures a network interface with a link local address. We can do static, automatic, or scripts, much like with IP version 4. And if I want to troubleshoot it, I'll go about it about the same way. So we've got file sharing for Windows 10. It allows us to share files from any folder on your computer or the public folder with another computer user on your LAN. So we could share a public folder. We can password protect a folder to where others can access it. It's shared, but it's also password protected. Now, you've got to be careful what we share, how we share it. Decide who's going to access it and what they can do. That'd be like sharing your credit card information. I don't want everybody getting that information, but there may be a need at some point that I have to allow somebody to get that information. I don't want it to be public, so I can define who accesses it and how it's accessed. I can have a local file being shared out, or I can have files shared to the domain or files shared from the domain. So we can create a shared folder. I've got a share with menu item. Go right on down the line, sharing. So here's the file. We can go through and determine how we're going to share it. We've got advanced sharing. Keep in mind that if you're going to share something out, you need the appropriate permissions, and we're setting NTF permissions by default when it comes to all the objects, all the files and folders on our machine or on our system. So the most restrictive permissions are effective to control permissions and who gets access to them. So I've decided I've got this file. It's called marketing properties. We'll go share it, advanced sharing, and how many people connect to it at one time, who, how, when. We'll go set all those permissions. So we share this folder, share the name, limit number of users, comments, permissions, caching. What kind of permissions? Is it full control, change, read? Sometimes you may want to share something. All you can do is read it. I don't want you to modify it. You can just go look at it. That's sharing information. But you're not relinquishing control of the ability to modify those things. Here we go, computer management. We can look at the shares, see what's currently being shared out, and how many are currently being connected to. So we've got internet connectivity, and that's how a computer connects to the internet, and it varies depending on whether a single computer or multiple computers are using an internet connection. Now, I can share out a connection on my computer and have other computers connect to mine, and that I would be their go-between to get to the internet. So we've got a single computer internet connectivity, got a cable. Almost all cable companies offer high-speed internet access. So if you can get internet access, or ISP we'd call it, Internet Service Provider, through a cable company. They've got a cable modem that'd be used, and you get your IP address from them. Now, we've also got an option which is a DSL, or digital subscriber line. It's traditionally through a phone company and uses a phone line. So it's different types of cabling that are being used. Traditionally, cable is providing faster internet access, but over time, DSL is getting better. One of the issues with DSL is the faster you are from the node, the worse your signal is going to be and the lower your bandwidth is going to be. But they've upped their game in the connectivity that they've got between the nodes, or between the clients and the nodes. We've also got dial-up, which is not used much anymore. That's from decades past. And you'd have a modem that connects through dial-up to another access point on the internet, and it's through the phone line. Now, one of the most common today is a wireless WAN, where you've got wireless access points and you just connect to it. Now, we'll see it a lot with, let's say I've got a wireless device, a phone. I've got a phone that's connected to the internet, or to my phone provider, my mobile phone provider. Okay. So my phone is talking on the phone system, and I can also have internet through my phone system. I can then tether that internet connection and share it out with others, and I'll have my own little wireless WAN by sharing my internet connectivity. Okay. Wireless networks allow the transfer of data without a physical connection. Windows 10 provides a strong foundation for wireless technology, and if we're using wireless technology, we need certain levels of security, and we've got what we call a wireless access point, and that is the device that we're connecting to that is hardwired to the network. So we're connecting to the wireless access point wirelessly, and then that WAP or wireless access point connects to the physical network on a physical cable. Now, there's protocols that are being used to talk to that WAP or wireless access point. The wireless access point has a set security identifier, SSID, and that's how we identify which one's which. We use them in what we call 802.11 mode. And 802.11, that's a protocol of communication that we will talk to that wireless access point via. And that's created by IEEE, and we've got different versions over time. I think current we're looking at 802.11 AC. And we've got security methods that take place. Now, manually connect to a wireless network, connect to a network, copy a profile from a flash drive, command line utility, configure group policy, or use Wi-Fi sense and ways to create a connection. And when it comes to wireless connections, we've got wireless security, but we've also got the ability to have no authentication. This thing's wide open. Anybody can access it. We've also got WPA2 personal, WPA2 enterprise, and 802.1x. There's 3 encryption types that are available when we're talking about Windows 10: none, WEP, and AES. Now, WEP's outdated. It's fairly easily hacked because it's low-level encryption. And if we're going to manage a wireless connection, it's similar to managing a wired connection. We go in, look at the details and the wireless properties. Disable, diagnose the connection just like any other. See how many packets were sent, how many were received. We've got this, I want to say new technology. We've got what we call the Internet of Things. And the Internet of Things, what that boils down to is devices that are connected to a network, traditionally via a wireless connection, to send data. It could be sensors, switches. It varies on what it is. Your microwave, your codeless phones could interfere with the signal, and these devices are able to talk across the network, and we're seeing it more and more often. Now, they're using that same 802.11 standard. These 802.11 standards, they happen at a specific frequency, and there's a distance that this signal can be sent. So let's say you're in a very big building and there's a lot of walls in it, and your access point, or your WAP, is in one corner of the building. The opposite corner of the building may not have much of a signal. So what would be needed is would need to repeat that signal or have some go-between. You can call it a repeater, if you will. All right. In Windows 10, we've got a host-based firewall integrated into Windows 10. It evaluates each packet as it arrives and determines whether the packet is allowed or denied. So it's kind of like a bouncer sitting out the club to check and see who comes and goes. We've got that integrated into Windows 10. So it's always protecting us. Having updates installed makes that more effective. So basic firewall configuration is that Windows 10 allows custom firewall settings for each type of network location, whether it's public or private. And we have to determine when we make that connection, whether it's a public or private, and how we want to handle communication with that network. When Windows Firewall is enabled, the default configuration blocks all incoming packets except for specifically configured exceptions. There's no option to block all incoming connections. No exceptions are allowed. So here's our firewall, and we can go through and configure it there. Turn different aspects on and off. We've got advanced firewall configuration, allows us to configure more complex rules, outgoing filtering, and different rules. So here's another shot of it when it comes to the advanced firewall configuration and how we go configure the specific properties associated with the firewall. How I can enable or disable Windows Firewall, configure inbound connections, configure outbound connections, customize protected network connections, customize settings, and customize logging in each profile of the Windows Firewall properties. So we've got IPsec, used Windows Firewall and Advanced Security Utility to configure IPsec settings. IPsec's default settings can configure key exchange, data protection, and authentication mode. IPsec exceptions settings you can configure are exempt ICMP from IPsec, or none, or advanced or custom. And here's our interface for it. You can view and edit firewall rules and change the settings. Okay. Here we are with new outbound rules. We can go set how we want it. Allow a connection, allow the connection if it's secure. And we can create new computer security rules. And we've got more videos on this so that it's not all crammed into this one. This is just an overview of everything. Okay. We can monitor Windows Firewall rules and connections. And when it comes to Homegroup Networks, primarily uses IP version 6 and link local addresses to enable communication between homegroup members, discovery of computers and their names on the local networks automatically by default. And a computer can only create a home group when it has a network interface connected as a home network location and is not joined to a domain. So network security or network sharing center is a central location to view and access network information. Windows 10 is a network aware and can sense which network location it's connected to. Network connections are composed of clients, services, protocols, and drivers. Important configuration concepts in IP4 are IP addresses, subnet masks, default gateways, DNS, and WINS. Windows 10 can obtain IP configuration information from static configuration data, DHCP, APIPA, or an alternate IP configuration. Windows 10 uses IP version 6 to support peer-to-peer networking applications. Sharing the public folder is an easy way to share files on a network. When you share any folder, you can use Share tab. It's in the File Explorer or the Share With menu item. The primary technologies for connecting to the internet are cable, DSL, wireless wide area network or WWAN, and dial-up. ICS configures Windows 10 as a router to share an internet connection. Wireless networking in Windows 10 supports different versions of IEEE, the 802.11 standards, and Windows Firewall is a host-based firewall included in Windows 10. Homegroup Networking allows home users to share categories of data through libraries. So that's it. I'll see you in the next chapter. Thanks again, gang.